Hey there, advanced math. On to solving algebraic equation strategy number 2. Use drawings today. Drawings are great for understanding problems. They only tend to work in situations where you have whole numbers in the problems, but it's a really good strategy when you do, and it really helps you understand what you're doing when I show you strat number 3. So go ahead and make this your next title, and close your math notebook up and think with me when you're done. Alright, we've done the common sense strategy so far. Let me remind you how that worked real fast. So we looked at problems like this. Bison has a job at a restaurant where he... Bison, that's not a name. Bryson. Typo. Bryson has a job at a restaurant where he gets paid $10 for each hour of work. Last week, he also got a $100 bonus. Woo! For working an emergency shift when somebody got sick. If Bryson earned $250 last week, write and solve an equation for how many hours he worked. So what we know about Bryson's money, he made $250, and we're going to write an equation to try to figure out how he got that. So he got $10 for each hour of work. Doesn't look like I know how many hours he worked. That's my variable. So if I take however many hours he worked times 10, I would get $250, except he didn't just work hours last week. He also got that $100 bonus. So he got $10 for each hour. So like if he worked 5 hours, that'd be $50. If he worked 7 hours, that'd be $70, and so on. He also got $100 extra for helping out. And yesterday our strategy was just common sense, to look at that and say, okay, well, for this to work, if he made $100 from the bonus, $250 altogether, this would have to be $150. And if that's $150, it would be 10 times 15 hours. And we just kind of figured it out without really doing a lot of math, just kind of common sense. So sometimes common sense gets a little tough. The numbers get bigger or the situation gets more complicated, and you can't always just look at it and tell the answer. So I want to start giving you some strategies to use where you can actually problem solve, and drawing is going to be the first one. So let's look at this one. 331 students went on a field trip, 6 buses were filled, and 7 students traveled in cars. How many students were on each bus? So when I make my equation, looks like what I know is equal is the number of students. The number of students on the trip is obviously equal to the number of students who traveled. And so I know that 331 students were on the trip. And let's see how they got there. So 6 buses were filled. And the question is how many students were on each bus. So I don't know how many kids were on the bus. That's what I'm looking for. So let's make, I hate using B. I'll just use a capital B. Lowercase b looks like a 6. So I had 6 buses times however many students were on each bus. I don't know. And then another 7 kids that went in their car. And all that turned out to be 331 kids. This is maybe, you might be able to common sense this. The numbers have gotten a little big on me, and it's hard for me to use the common sense strategy. So I'd like to have another strategy to solve problems like this, so I didn't feel like I just had to figure it out in my head. So today's strategy is going to be kind of drawing the situation. If you'll remember, several lessons ago, we were using kind of X tiles that look like this when we combine like terms, and 1 tiles that looked like this. And I'll often use those to kind of set this situation up. Where I'm looking at this, this side, I'm not going to draw 331 ones. I'm just going to draw, a 331. So I can imagine it there. And then over here, I've got 6 of the variable blocks. 1, 2, 3. These are the buses for, even kind of look like buses. So I've got 6 buses that have some kids on it. Plus I've got these other 7 kids here. And so what I'm really trying to do is figure out, these are all equal, and I'm trying to figure out how many of these there must have been. How many kids must have been on each one of these buses. So that's one way I draw it. Sometimes if I want to draw it faster, I'm okay either way. Instead of drawing the X kind of tiles, sometimes I'll just draw it like this. I'll do the same thing here, the 331, and I'll just draw B's or X's instead of the blocks. 2, 3, 4, 5, 6, and then the 7. That can be a little faster to draw sometimes, and I just draw the variable. And so what I'm trying to do is figure out what is each of these B's. They have to be the same because they're the same variable. And I'm going to try to use my drawing to figure out what it is. So if 331 kids total are on this trip and 7 are in the cars, it'd be nice if I didn't have these 7 kids in the cars to worry about. So I can kind of, if I take these 7 kids that are on the trip and are in the car out of the situation, I'm gonna need a little more space here. How about this? I'm gonna use this one because I have more room underneath it. So what I like to do really is let's not worry about the 7 kids in the car. Let's just worry about the kids on the bus. So if I kind of take them out of the situation, take them away, I'm also going to take them out of this side, because if I'm going to take them out of the travel, they're not on the buses, so I don't want to use them to figure out who's on the bus. I'm also going to take them away from the total so that I don't include them here. So if I take them away, just the kids on the buses, 7 less, that would be what, 324 kids were on the buses, and there's still the 6 buses. And now I can kind of look at this as a little easier to tell. If I don't worry about the car kids here or here, I can use my drawing and say, okay, now I've got 6 buses and I've got 324 students. All I've got to do is divide those 324 onto the 6 buses, and I can figure out how many there were. So let me calculator out. And let me divide those 324 kids onto 6 buses, and then I can tell there's 54 kids on each bus. And the drawing helped me kind of see what I was doing and figure that out kind of easily. If I go back and check that now, if I go back to my original drawing and make sure if each of these buses had 54 kids on it, that would be 54 times 6 plus the 7 in the car, and I sure do get 331 kids. So it works out. So each one of the buses, each one of the B's was a 54. All right. So I think the drawing strategy helps. It really lets me see what I'm doing and manipulate the numbers in a way that helps me solve the problem. All right, let's do one together. Open up your notebook. This is another common problem you see in algebra, and we're going to solve it a similar way. So it says the sum of 3 consecutive numbers is 72. What are the smallest of these numbers? What's the smallest? Maybe what is probably a better way to say that. What is the smallest? So I've got these 3 numbers. Consecutive means in a row. So it means I'm adding 10 plus 11 plus 12, or 23 plus 24 plus 25. So I'm adding 3 numbers in a row. I don't know what any of them are. So it kind of sounds like I need 3 variables, right? Like a plus b plus c equals 72. But I don't. I actually can do this with just 1 variable. Since I know they're in a row, whatever this first number is, we'll call it a, b is 1 more than it because they're in a row. So instead of giving it a new name, I can just call it a plus 1. It's 1 more than the first number. And same thing with c. Since I know the numbers are in a row, that number doesn't need its own variable. I can redo it with the first variable and just call it a plus 2. So I can really set this situation up with 3 variables with 1 variable instead of 3. So now I've got this equation where a plus 1 plus a plus 2 is equal to 72. And if I find out what a is the smallest number. And so that'll give me my answer. So all I have to do is figure out what a is. So it's kind of a complicated setup right now. It's a lot to solve. I think what I'm going to do then, I'm going to use my drawing strategy. And I can say, okay, so I'm going to have on this side of the equation, I have a, and a. Or if you'd rather, variable bar, variable bar, variable bar. And the 1 and the 2. Since there's not many, I can draw them like that. And on this side, I have 72. And so I'm trying to figure out what each of these A bars is, and then I'll know the answer. So it would be nice if I didn't, these 3 kind of make it a little harder to figure out, because if I just had these, I could divide this number into 3 parts and know. So I would really like to I would like to know what 3a equals. A plus A equals, and that would be a lot easier than dealing with this. So what I want to do, if these weren't here, that'd be nice. These are like the students in the cars in the last problem. I'd really like to get rid of those and just find out my A. So that's fine. So what I'm going to do, I can do that. I'm going to take these away from this side, and let me see if I can explain this better. So if I know a plus 1 plus 1 plus 1 equals 72, then what I really know is just the a's equal 3 less than that, because I'm going to add them up, then add 3, and get 72. So I know that what I can really do is say, well, just the a's, if these weren't here, just the a's would be 3 less. So just the a's equal 69. Hope that makes sense. What I'm going to do is, I don't want to deal with these. I want to know just what the a's equal. So if I get a plus a is 69, then I add the 3, I'll get 72. So a plus a is 69, and then now I just have to divide the 69 onto the 3a's, right? And I'll know the answer. Some number 3 times equals 69 means it is, I believe it's going to be 23. So A, I can just look at that and say A equals 23. A equals 23. So that means the smallest number is 23. And my 3 numbers were 23, 24, and 25. Oh my gosh, that was one of my random answers. Look at that. I did not know that when I did it. I had not worked it out yet. If I add up 23 plus 24 plus 25, I indeed get 72. All right, that's how you use the drawing strategy to solve algebraic problems that are a little harder to solve than you can just do with the common sense strategy. If you need to go back and watch these again, please do. This is very new, and you've only seen 2 examples so far, and I want you to be really prepared and successful when you get to class tomorrow for the U-Dos. So please go think through these again and make sure you really know what I'm doing and why I'm doing it at each step. And then once you've got at least the we-do written down, then you're all set, and I'll see you tomorrow.